The M1 version of R is great. Things are almost instantaneous. Is it much faster than any of the Intel versions I've worked with? Not really. I think the M1 really succeeds is that it requires very little energy. In the case of the MacBook Air, I'm running production quality scripts without even having a fan blowing. What's up, guys? It's Ernie from Cincy Brain Lab. It is August of 2021, and I am still amazed that Apple M1 is at the top of the single-thread performance benchmarks. We are seeing more Apple Silicon in the lab, and I want to give you a quick installation guide on a native M1 install of R and Rstudio. The piece of R most of us interface with is just the tip of the iceberg. Rstudio is a graphical interface that does all of its operations through the R interpreter. It's the R interpreter itself that actually executes the scripts, handles the data, and produces the output. Currently, Apple computers have either one of two types of CPUs. Both of these CPUs are quite different in their architecture, and so software between the two of them are not directly compatible. You can either have an Apple Silicon M1 chip, which is the newer chip, or an Intel chip on the inside. To make the transition smoother, Apple has allowed Intel applications to run on M1 chips translated through a software layer. The current version of Rstudio is built for Intel platforms, but runs pretty seamlessly through this Rosetta translation layer. The performance hit is fairly negligible, and in fact, sometimes it actually runs faster than an older Intel Mac. If you were to perform a Rstudio installation using the current directions on the website on an Apple Silicon processor, you are going to inadvertently install the Intel version of the R interpreter. The downside of this is that unlike the Rstudio graphical interface, where there aren't a ton of computations involved, having the Intel version of the R interpreter is really going to slow down your work. Any type of computational program, you really want it to run natively on the processor for the best speed. However, this does come with one major caveat. Most of us don't just use R. We use the libraries and frameworks associated with R. These have to be native also for M1. This is not that big of a deal. In fact, we've been using M1 Silicon R to generate some publication data. Most of the libraries that we are working with can be compiled right on your computer and then built for M1. So how well does it work? In our laboratory, we have a mixed environment of Linux, Windows, and different versions of Mac. The M1 version of R is great. It's stable, it's fast, and you can run it on a computer that requires minimal power and doesn't require a fan. For most of the stuff I run, things are almost instantaneous on the M1 version. Having an M1 native version of R really makes it comparable to the other computers in our lab. Is it much faster than any of the Intel versions I've worked with? Not really. The one use case where I think the M1 really succeeds is that it can run comparable to any of those other computers that requires very little energy. In the case of the MacBook Air, I'm running production quality scripts without even having a fan blowing. Let's start with installing the native M1R interpreter. It really is just knowing where to go and what packages to download. I'm at the R organization site for Mac. We have version 4.1.1. I found good compatibility with packages on this version, so I wouldn't hesitate to upgrade, especially if you're starting a new installation. We have both the Mac OS Intel, which is the first entry, and we have the Apple Silicon version. Download this package. Once it's downloaded, let's also type Rstudio into your search bar, the open source version, download Rstudio desktop. Here I'm going to hit download Rstudio for Mac. You're going to have a couple files in your download folder. Let's start by installing the R interpreter. If you've installed applications on the Mac before, this is standard installer. Confirm that this says ARM64. Accept the agreements. Install to the hard drive. Administrator password. Go ahead and check our R installation. I'm going to open up my terminal using Spotlight. Go ahead and type in just capital R. Here we are at the R interpreter command line. Confirm the platform is the ARM processor. It looks like we're running. To quit R, you're going to run the function quit, and I would hit no of saving the workspace. Next, let's install Rstudio. First, we mount the disk image. Then we just simply drag the Rstudio to the application folder. Shortcut, go to your application folder, find Rstudio, and run it. Starting Rstudio, you'll notice that the R version it's linked to is the Apple Silicon version. Now, I would assume that an M1 native Rstudio version is in the wings. However, regardless of the graphical interface, having the R interpreter native is really the big deal here. Let's take this version of R for a spin. Open a new blank script, and first identify where R is storing packages, and then we are going to load some common packages, and then we are going to run some functions. To identify where R is going to be storing his packages, type in .lib lowercase paths uppercase with parentheses, and then hit Command return, and you will see here the directory that R by default is storing packages. If you install another version of R on your computer, for example the Intel version, R is going to be able to separate the libraries from each based on this directory name that puts the CPU type in one of the subfolders. Why don't we load some common packages? And so the first package I personally like to install is a package manager, and the package manager I use is called Pacman. You can see how quickly that installed. R is actually using precompiled binaries for the Mac OS M1 chip because they are available. So instead of doing what is called compile from source, which is a time-consuming process, R is able to bring in packages very quickly directly from the CRAN repository. Pacman has a function called pload, which stands for package load, and here I can actually list a number of packages with just commas in between them. R will not only download the packages, but it will also load the libraries into memory. R has now completed installing these libraries, and why don't we try it out? Let's go ahead and try some of these functions out. First, load the dataset cars. I forget the variable name, so I'm just going to output a few rows. And you can see there speed and distance. I'm going to use my Pacman to load our theming function for ggplot, which is ggthemes, and that's going to install it. I'm actually going to pull in one of my favorite themes directly from GitHub, the theme publication by user KAundy. Now with that loaded, take the cars data set. I'm going to pipe it to a ggplot object. I'm going to make my x-axis equal to speed, my y-axis equal to distance. I'm going to then make the geometry align, and we are going to use the theme publication command. And here we have a plot object. And so hopefully that's helpful in having a functional M1 native R interpreter. I will be running some benchmarks against some of the other platforms in future videos just to get a sense of what a complex linear model might look like across all three. This is Ernie from Cincy Brainlab. If you like this type of data science content, please leave some comments below and tell us what else you'd like to see on our channel.